In this video, we will look at multiplying binomials through the use of generic rectangles. Before we look at a generic rectangle, let's go ahead and look at the algebra tiles that represent the rectangle x plus 2 times the quantity x plus 3. So here you can see that we have a rectangle that has a height of x plus 2 and a base of x plus 3, creating 4 regions. Now I can find the area of each region by doing base times height. So I have x times x, which gives me x squared, x times 2, which is 2x, x times 3, which is 3x, and 2 times 3, which is 6. So when we look at this representation, this is the area of the rectangle written as a product, base times height. I can also rewrite it by writing it as a sum, the sum of all the areas of the rectangles. So I get x squared plus, now I have to combine the 2x and the 3x to get 5x plus 6. Now let's use what we learned about the area model to make a generic rectangle. So I know when I'm multiplying a binomial times a binomial, I'm going to get 4 separate regions. So if I label one side x plus 3, I can label the other side 2x minus 5. Now I can find the area of each piece by multiplying the base times the height, and I can write the area inside each of the boxes. Now, as you recall in the last problem, this is the area of that rectangle written as a product. Now I can write the area written as a sum. 2x squared. Now I'm going to combine like terms and get plus x and then minus 15. So this is the area of that rectangle written as a sum. You can actually use the generic rectangle for more than just binomials. In this example, we have a binomial times a trinomial. So we can again use our generic rectangle to find the area of each piece, then add them together to get the total sum. So I'm going to find the area of each of the 6 rectangles and then combine like terms. So I end up with 6x to the third minus x squared minus 12x minus 5. Look at these examples and use what you learned about generic rectangles to multiply these binomials.